Hello and welcome to Golden Droplets episode number 33. In today's episode, we will be talking about how to conduct a fair and objective audit of a lab. This is a very important activity, and when done properly, it will benefit both the labs and the companies. So, once again, Golden Droplets episode number 33. Have a great day. The subject of this conversation today is about the audits that the persons and the geologists in general should do of the labs. And this subject came from a letter I received from geologists in Peru asking about the rules of the game. And it's a very good question. And because labs are very important for us as geologists. The most important part, of course, is a good sample, the sample that is representative of what we are looking for. But then the lab is the one that gives us the values. With these values, we do all the estimations and the anomalies, interpretation anomaly. We put drills, we put trenches, etc., etc. So labs are very important for the geologist. Now, the question basically that this person asked me was about doing an impromptu, unannounced audit. And my comment on this subject is that most of the labs, especially the recognized ones, SGS, ACT Labs, ACME, etc., they have a policy of open doors, which means that you can go anytime, any day, and ask to do an audit, and they will allow you to do it. It's that they will specifically prepare if you call it and say, well, I would like to do a visit on Monday at 3 o'clock. It's not that they're going to do anything better for that, but I will suggest you to call ahead, because you never know, you may get there and they had a rush hour order and they really don't have time to properly show you the labs, etc. Or there is a problem, technical problem, an electrical problem, and the machines are not working or whatever. Okay, so it's much better to announce your visit. So you call them ahead and say, okay, I would like to do an audit, and there are so many people come with me, and this will be the time and hour. Will you be amenable for that? So that is my answer. Don't do impromptu visits. It's better to call ahead and organize the visit. Now, the other thing I used to say is when you do the visit, you talk to the person that will be taking you. I mean, there will be usually a chemist or a lab worker or a manager that will go with you and do the audit. You just tell them, listen, I'm a sample. Okay, just treat me. I'm a sample. I just got to the lab. Show me what you do with me as a sample. This is very useful because that way you will go step by step through all the process of auditing the lab. And usually this process starts right at the front door where they get the samples, they organize, they check the numeration. And here is one thing that you need to figure out. Do they have a procedure to follow in case, for example, there are two samples with the same number, or a missing sample, or a sample that is really clearly have been opened, etc. Because usually labs have this kind of procedures. This is part of the QA, and those who knows me, they know that I have given several webinars about QA QC and the importance 43101. I've shown this book here, which has all the basic information for the QA and QC. So QA is very important, and the lab should have a process to check, as I said, the number, the sequencing number, duplicate numbers, and very important, the bugs that are clearly messed with. Then the next step, of course, is weight. They weight samples, and this is really a very useful thing. The geologists, before sending the sample, they should also weigh the sample. As soon as the lab finish weighting all the sample, they should send that information back to the geologist. And the geologist should compare those two to make sure that if a sample weighted 5 kilos when it left the camp, is not weighing 4 kilograms at the lab. So that is a way of controlling the chain of custody. The other thing very important is that you use the weight of the sample as a way of normalizing your data. As I say, it's not the same sample that I have 1 gram per ton of gold, and the original volume was 500 grams, with another sample that have the same amount of gold, but the original sample weight was 3 kilograms. Okay, so these things allow you to normalize your data before processing. The next step, of course, is the oven. We need to dry the samples. Even when they come apparently dry, they need to be thoroughly dry. Now, the most important point here is to check the temperature of the oven. If you are working with 52, 62 elements, I mean the full multi-element analysis, you will like the temperature of the oven not to rise above 70 to 80 degrees. So you will keep all the mercury, the loss of the under emission, etc. If you are just interested in fire assay, etc., then the temperature can be higher at 100 or whatever. Convection ovens are the best. It's not something that you can control, but it's not good to know. The convection ovens are faster and they give a much better result in drying the sample. What you need to check, if possible, because if the oven is functioning, you cannot come in. That is one of the reasons why it's better to announce your visit. Is to go inside the oven and check for fractures. I mean, cleanliness, erosion, whatever. Also check that each sample has its number. Okay, this is very important. And I will do a little stop here and also mention one important fact. You can do audits to the lab basically from 2 points of view. For example, if you're a qualified person, and you're writing a report for a company, it is usually very good to do an audit to the lab or labs that deals with that company. That will be part of your 43101. But even if you're not writing a 43101, this is the normal day work of a geologist. You should do audits of the labs at least once a month. And in my personal opinion, budget permitting, it is very good to bring more geologists to this visit so they will understand how the lab works is better. I also invite times the personnel from the lab to visit the field so they will see how we take the samples, and that creates a very good environment between the lab and the company, which goes very far to get much better results. Another point that is very important when you are a geologist work for a company, and I mentioned this many times before in several courses that I have given, that you need to have a contract with the lab. And it's not only for the cost, the turnaround, and this thing. No, you need to have in that contract things like what kind of quality control you're going to use. What will happen if a blank fails, or a duplicate fails, or a standard fails? How frequently you want machines to be clean? All these things need to be very clear in a written contract. Also, who's going to pay the repeats, whose fault it is. So once you have this on a contract that is part of the QA, then things are going to move more easily. Okay, now you're dry. Go to the first line of machinery, which are the crushers. And thing is, you need to understand, you're taking a sample in the field. That is, let's say you're doing some sample, you're getting 100, 200 grams of material. And with that, you want to get an idea of the gold content in the region. So it is really a hard sell. So we really need to make every effort, every possible effort to get in field the best sample possible. And then the lab need to get this amount sample. If it is, as I say, if it is so sample, maybe 200 gram, 300 gram. If it is a drill core, maybe 4 or 5 kilograms, etc. And they need to reduce that amount to 5 gram, 15 gram, 1 gram, etc. And doing that, they need to make sure that that final weight is representative of the initial weight of the sample. For that, the lab goes to a two-step process. First, they crush the sample, they sieve it, then they homogenize, and they do quart splitting using a splitter. And they repeat the process until they get down to a more manageable weight, usually 50, 100 grams, or 20 grams, depends. And then they pass to the next step, which is the pulverizer. Now, when they are doing the crushing, most of the labs will do a clean between samples using a blank, their own blank, which is usually a quartz, sand, etc., that they know for a fact that has no gold values. And if you ask, the lab can provide you the result of the control that they do with this sand. So every sample, crush, they put a blank. Crush, they put a blank. Crush, they put a blank. Now, one of the most important things that you need to be aware in a lab, from the moment you enter the lab, it's usually a big hangar, okay? From the moment you enter, is the cleanliness. You need to look for a place as a geologist that visit a lab that I was running in a company in Colombia. He used to say, "You can eat from the floor in this place." So really, it must be clean. And sometimes it looks clean, but you need to really make sure that it's clean. One trick of the tray that I use is I will have a camera, normal camera, with a flash, and I will take a picture through the air with a flash. If there is dust in the area, the flash will pick it up, and you will see the little specks in the photography. Another place to look are in the lights. They generate electricity, of course, and they collect dust. So if you see a lamp that is supposed to be white but is now yellow because of the amount of dust it have, that has a problem. And sometimes simple thing like you see the dust in the floor. So that cannot be allowed. Okay. There are now systems that extract the dust from these crushing and pulverizing machines. Best labs have system that the machines are enclosed inside a, a, a closed unit that controls to the 100% the dust emission. And those are the best labs, of course. They are reducing the amount of pollutants, dust that can contaminate samples, especially if you are in at the level of a mine where you really need to know exactly how many milligrams of gold you have in the samples. Okay, so check on the quality of the extractors. Not all the labs have this enclosed system that they actually they need to open a little door, put the sample in, close the door, press a button. When they finish, open a lower door and take the material out. I mean, it's really, really very good. Also, big labs, good labs, have uh, the opportunity of have two lines of machinery, one dedicated specifically to ore material and one for the normal exploration, which is a very good practice. So you check on the cleanliness. This is very important. On the extraction, the vacuum, the quality of the machine, the type of the machine, how they are, if they are well kept, etc., etc. So those things are really, really important. Now, once the material has been downgraded, I mean, quartered down to a more manageable weight, then they go to the pulverizers. And these are this is the most important step. This is where the material gets pulverized down to 160 mesh or sometimes even more. And because of this, the machines need to be cleaned between sample with air. They clean it up with pressure air, and then sometimes with blanks every 5-10 samples, also with blank. These are the things that you can discuss with the lab, with what frequency you want this to be done. Okay, now let's say that now the sample is prepared. You have your, let's say, 100 or 50 grams of material. Supposedly is down to the minus 160 mesh, etc. The lab, and this was the most important step in any auditing, was to check the granulometry. Check if the sample really passed the 120, whatever the mesh that you have with the lab for your analysis. Some years ago, when LIMS came, LIMS is an electronic system that basically all the labs use now. And what they do, they control all the steps. And if some step doesn't qualify, doesn't check, it stops the process automatically, and you need to go back and fix it. So basically, if a lab is using the LIMS system, you can just ask for the result. But if a lab doesn't have the LIMS system, you must do this, and the lab will comply. You will go and check, select a sample or two, and ask the technician to sieve it to make sure that it passes the whatever mesh you are using. This is very important because this is how you can guarantee that this gram, 10 gram, 5 gram, 50 grams that is going to the analysis is representative of the 5 kilograms of rock that came to the lab, assuming that your sample that you took in the field is representative for the deposit. So this way we get a sample that is representative from the initial material. I also mentioned that you can introduce quality controls at different steps. You can put quality control after the trenching, after the trenching, after the crushing, after the pulverization, etc. So if there is an error, it will be easy to fix where it is. Okay, and then after that, there is a moment of where you, as the geologist, have arranged to put your quality controls, your blanks, your duplicates, and your standards. So usually what is happening is that the lab will prepare all the pulps in little craft paper bags, and there will be a special room where you can go, or the designated person can go and add the duplicates, blanks, etc. So the lab will not know which day. So this is basically what you do during the visit. And of course, then you need to check how the lab, and I'm talking about right now basically the preparation part of the lab, okay? How the lab generates reports about the samples. Usually, most of the labs now have web pages where you can do the tracking. You can log in and say, okay, my samples have already been prepared. They are now on its way to Peru for analysis, or to Canada, or whatever. Okay, so that is the part that you can do, and also you can check the storage, because sometimes, no, most of the time, the lab will keep your rejects from 3 to 6 months, and then or discard it or return it to you, or keep it for longer. And as a good practice, I always recommend my geologists to keep the pulps, bring the pulps. Multi-element, are you doing fire assay? Are you doing the enzyme leach, MMI? This system have their own chemical procedures, so you, as a geologist, you need to be aware of them, and you just need to do also. In this case, you continue telling the chemist, because at this time it's usually a chemist that will go with you through the lab. The big labs usually have the preparation facility next to the lab. Sometimes no, sometimes the samples are only prepared in the country and sent to another country to do the lab. In that case, it's more difficult to do the lab, although I will recommend that somehow you try to, at least once every 6 months, do a full audit of the chemical part of the lab. So again, here is everything is cleanliness. Must be very clean. There are few tricks of this. For example, if you're doing a fire assay by the gravimetric way, so you need to weight the actual amount of gold. The balance that they use, first of all, it must be there must be a standard, so you can calibrate every day. Even every sheet need to be calibrated. But the thing that you need to check is that there are no variations. So usually this weight are put a very solid cement table. And what you check is you just go and hit on the table close to the the weight and see if it is affected. Okay, so it should not be affected. I have been in very primitive lab where they in the tropics need to turn off the air conditioning while doing the testing because the vibration of the air conditioning unit will affect the weight. And of course, because we are talking 35 degrees and humidity, they cannot work in a closed little room for more than, I don't know, 5, 10 samples every hour. So it was really, really bad. They fix it, of course. What else? You check the controls, the amount of controls that they have for the labs, for the machines. And again, as I mentioned, LIMS now controls everything that does. So if there is some problem, for example, they were using the ICP-MS, and when they tried to calibrate it, something was wrong. The system will not allow the process to continue until you fix that. But in any case, you can ask if they don't have the links, for example, you can go and check because the lab will use own blanks, its own duplicates, and its own standards. So basically, when they give you a result, you're getting a result that is the best that they can do. But that doesn't mean that you need to believe or to accept that without your own quality controls. You need to have your own blanks, your own duplicates, and your own standard independent from the labs. And that's the way you do the control of the labs. Now, I want to show you because this is a process that needs to be documented. And I have created a quality assurance document that me to that paper, and I do the audit of the whole lab. And at the end, we get to some conclusion. We sign, and I give it to the lab, and I keep a copy to myself. You can create your own documents, or you can contact me at valsvg@gmail.com. I will gladly send a copy of this document, which I will show you right now. Okay, so I hope you are seeing my screen. So this is the document, okay? So you have the name of the lab, the date, and one thing I didn't mention, and this can really affect the quality of the lab. If you have new equipment, they may brought a new ICP MS machine or a new crusher, etc. So all these things you need to check and take a note of it, especially if there are, as I mentioned, some labs, big labs, HGS does this all the time. They have a line for ore mineralization and a line for normal exploration. So that is what it means dedicated. Now, are changes in the personnel, okay? Were they required by the client or by the lab? Is this a temporary, is this related to COVID, etc.? So you need to know this. Sometimes I have been in this business for 7 years, and I have been in the bad or difficult situation of calling a lab manager and say, you know, you need to, because he's really screwed thing and he doesn't want to change. So all these changes need to be specified if there have been any changes. Then what do they do with the crucibles, the cupels? Usually the glassware is recycled, it's not recycled, it's clean and used again. The crucibles sometimes are used again. The couples are used again. Okay. Again, are there any changes? For example, they may the lab may have instituted a new shift at night, and this may affect the work. So all these parts of the things of human and resources be checked also during the of the lab. Now, also, does the lab use LIMS or class, or how do they control the system? Do they use Excel? They're using code bars for the samples. Many labs will give you the, the booklets with the numbers that already have a code, barcode, so they can read it, and it's for them. It's a non-conformity report that is the QA. For example, if what do the lab does when it receives a sample that is clearly being open, or missing a number, or 3 times the same number. Okay, all these things have to be checked by you when you do the audit. Then, are there any changes with the lab itself? For example, the lab could have acquired a new ISO, a new qualification. Those data in the round robins, that is really important. I mean, we cannot, and you are not forced to work only with labs that participate in round robins. But if you have the option, this because they are continuously checking their quality. What type of internal standard do they use? Usually, RAPS is the company that provides the control for basically all labs. What kind of data storage do they use? What system do they use? A computer base, a website to control the samples, etc. Now, all the things that you see, the little red asterisk, that means that you need to take a picture of. So this is what I was telling you. You're going to go through the different steps, okay, and looking, okay, the sorting area, how does it look? Poor, good, excellent, and observation. The work order book or the system that they use, check the sequential numbers, the cleaning and control, and review the system computer of data entry, okay, to know that all these things are working okay. Is the space good enough? I mean, sometimes you get to a lab that they really don't have the space to organize well the samples, so they need to do it outside. Well, that's it's okay if it is raining, or the space outside is clean enough. Again, this is very important. Do they have a separate line for or sample? That's not mandatory, but it's good if they have it. Check temperature of the oven, as I mentioned. The difference is, if you want to get mercury, you need to use 70 degrees. Check inside the oven if possible, okay, for the cleanness, split, fracture, oxidation, whatever. Bags or the number of the bags are placed with the sample. This is very important. Then again, this is thing I was mentioning about checking the mesh that they are using. They should be stainless steel. Are they dusting the crusher? Frequency of cleaning material. A note from where they cut their blanks they're using, and ask for the result of the chemical control that they do on their own blanks. The splitter, for example, there is a mathematical theory saying that the amount of channels in the splitter should be uneven. And at the beginning, they were all even. Now I've seen more and more labs going to the uneven thing. So you just mentioned to the lab. So you check all these things, and again, it's poor, good, or excellent. You make your comments. ask, sorry, you can ask to weight a sample for control, and for the pulverizer, this is what I mentioned before, that you need to check that each fraction pass the mesh that was designed for. For example, is 95% passing the minus 100 mesh, 150 mesh, and or 65% passing the minus 200 mesh. In a batch, the lab prepare, and we are already at the lab part. The lab prepare batches, usually 40 to something. In each, the lab will have its own blanks, duplicates, and standards, and you need to check that. In the specific case of the fire assets, use a method is called the copper marker, which they put a little piece of copper in the cupels just to check the position and the number of the samples when they are heated and melted. And then if there are any key issues, you just discuss it here, you make observations, make some recommendations, this is what we're going to be doing, this is going I will be checking next time, etc., etc. And then of course the photographic evidence you sign, and the lab representative sign, and you get this document. This is a very important document. It's at some point you will have a mining analyst coming to visit your project. This is a documentation that you can show. So basically, this is what I wanted to talk about, the how to do a fair audit of your lab. The lab is your friend. You need to be in great coordination with the labs, and usually the labs will love when the geologists get involved. They will never be against an audit like this because it's aimed to, I assume that at some point somebody may have some extra questions. As I mentioned, my email is vg@gmail.com. You can email and I will do my best to answer. So thank you very much for your attention, and until the next time, have a great day.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.